think that, this man, V&Vi, just giving us a lot of stories, even himself that he doesn't know anything about organic chemistry. Well, I don't know everything, but I know the small portions of organic chemistry. Okay, so if that's the case, now we say, okay, so it's still a partially positive, partially negative, nucleophile, electrophile. So it means that this guy brings his also its electrons here. Right? So then we have what? Simply have CH3. We have carbon. Let me just write it clearly for you. And this is carbon. And this is carbon. Methyl. Hydrogen. Then here, you know that, no. Here you have partially positive, right? Well, this one's the one that have partially positive. CH3, okay. So this is CH3. So this is CH3, one of them there. And that's this one, so this is CH3, 2. And this is carbon. Okay, carbon. This is carbon. Let me restart it. Let us start it here. So here we have carbon, partially negative, partially positive. And this one, we had the carbon partially positive, but we have methyl group now. And hence, this has 2 hydrogens. Right? Behind this guy, we have CH3. And also here CH3. That's all. Plus what? Bromine, which is partially negative. And this bromine, we have brought it in this state from here to here. So this is no longer partially positive. And here we don't have, no longer have bromine. So here we have bromo. Right? So that's our final product. So we took organic compounds, we react to another organic compounds. And finally we get a single organic compound. So for that case, for example, if you go back to our question, so we say this is an overall reaction. Say overall reaction. So the general reaction. Reactant, we have CH3, and then you have what? You have CH, or you have CH3, and then you have what? You have double bond, CH2. Plus what? Plus CH3, bromine. This will make what? This will make that once. So it will make CH3. Then you have carbon. Let's say that you have CH3 there. Then at the top we have bromine. It is the same. Then here we have CH2. But here we have CH3. So that is our end product. Right? Okay. So this will be example 6. For example 5B. And this is homework. Homework what? 06. Homework 6 according to the session. Complete this reaction. Complete the reaction below. with mechanism by showing mechanism. Okay, so complete that reactions with mechanism and send the answer to me through the comment section. Okay, so I want to take you onto the third rule and the fourth rule. I believe you enjoy the beauty of showing mechanism of organic reactions. So you see, when you are taking my sessions, you won't be confused and thinking that you have to claim this. So I'll be reducing your tendency of claiming this reaction. Because can you imagine, what if you put the information of organic chemistry, you forget what has been stated in physical chemistry, what has been stated in organic, what it has been, you have learned in general chemistry. Okay, so we are going for the rule number 3. Oh, of course, the an accident. My God. My God. Third rule. The third rule is concerned with the compounds which acts as nucleophile. By using localized pi bond situated between two non-identical. Remember the first one, it was between two identical, non-identical atoms. Atoms. Between two non-identical atoms. So we say that the pi bond pi bond between non-identical atom breaks to allow the addition of atoms to the organic reaction. So I have an example here of a ketone. So this will be example 6. Yeah? Make sure that you do the homework. Example 6. Complete the following organic reaction with mechanism. We have organic compound here. Yes. So we know that you don't know aromatic compounds yet. We have just made a strong revision. In case that you want to overboard your sense giving in order to participate the running cost for this program, so that more than 50 sessions of organic chemistry will be in air. Because can you imagine, this is the first topic, we have 6 sessions, so you still have the 7 sessions and possibly even the 8th session, even the 9 sessions. So can you imagine that if each topic will give out 10 sessions, so 10 times 9, 90 sessions. Really, it will be like kind of being tired or kind of experiencing fatigue for students to go through the 50 or the 90 videos. But no way out, that's according to the syllabus. And you're advanced students, you are no longer an ordinary secondary education student. You are advanced students who you are approaching to solve real life problems. So you have to think in terms of advanced level. Okay, so this rule, the third rule, is concerned with the compounds which act as nucleophile by using what? By using localized pi bonds situated between 2 non-identical atoms. So the second rule was between the 2 identical atoms, right? So what do we say here? We say that the pi bond between the non-identical atoms breaks to allow the additions of 4 atoms to the organic compounds. The organic compound. Organic compounds. So have example 6. Complete the following organic reaction with mechanism. So this is ketone, this is benzene, this is the attached group for the ketones, and this is alkyl halide, but it has some substituent groups. So then we say that you can pause the video and then you can complete the reactions mechanism yourself. Yes, you can try it. Pause the video for 3 seconds, take a piece of paper, and then try to complete the chemical reactions. Then you continue to watch the video to see your outcomes or your results. So you say solution. Solution. So solution, we say that, we have this benzene. We have this guy. And you guys, how about in some baskets? You have to tell me at the end whether they've got diploma or some A-level. Somebody's been my teacher. So, okay, my teacher. So, C3. Okay? And then here we have what? We have carbon, we have chlorine, we have CH3, we have CH3, we have CH3. Right? Start the opening structure. So listen carefully. Listen carefully. We said that these rules will be dealing with what? Localized with compounds, organic compounds which contain localized pi bond between the non-identical atoms. Where the localized pi bond, well, you can get confused with this ring structure. This is all about carbons. What about that? We're not talking about this aromatic or this benzene. We're talking about here. This is, we have a pi bond between carbons and the oxygen, and also we have sigma bonds between carbon and what? And oxygen. So what's going to happen there? Between oxygen and carbon, which is more electronegative? Why it is more electronegative compared to carbon? What evidence makes you to say that oxygen is more electronegative? You have to go back to your understanding of electronegativity. You have to compare the value of electronegative value between carbon and oxygen. Then you can say that this is more electronegative rather than this one. Otherwise you are speaking as a general student. So we break this bond like this. And then after we break this bond, this becomes partially negative and this becomes partially positive. The next state. So here we have carbon, here you have what? Methyl group. Here you have a sigma bond. This is partially negative, this is partially positive. Plus what? We didn't do anything else in CH3 carbons. CH3, then you have what? CH3, and here we have chlorine. Right? So, that's the case. So if this is the process, what do you say again? Here we have covalent bond between carbon and hydrogens, between carbon and carbon, between carbon and chlorine. But the covalent bond which can be broken easily is the one that has a high electronegativity difference, which you find between carbons and chlorine, because chlorine is more electronegative compared to carbons. Why? Because chlorine has high electronegativity value compared to electronegative value 40 of carbon. So these bonds will break, and then chlorine will withdraw both electrons that are being used in formation of covalent bond. So chlorine will become partially negative. You see now the necessity of general chemistry, and this is partially positive. So this is benzene, right? So this is benzene. Okay, so here we have carbon, and here we have oxygen. This is partially negative. This is partially positive. This is CH3. And here we are. So you have CH3, you have carbon, you have CH3, right? You have CH3. Okay? You have what? Partially positive. Plus what? Chlorine. Partially negative. So what happens here? So listen. So this is nucleophile, this is the electrophile. So this will be acting like a nucleophile. So nucleophile always, it's electron lava. It's a nucleus lava, not electron lava, it's a nuclear lava. So it means that, remember that always, just like in the previous rule, so the arrow will start from here and pass through the oxygens, which will take the incoming what? The incoming electrophile. This is the electrophile, this is the nucleophile. The same organic compounds act as nucleophile at the center as electrophile. This acts as electrophile. At the center acts as nucleophile in one part. This is electrophile. And this is acts like what? Nucleophile. So chlorine acts as a nucleophile. So, if that's the case now, the next thing are product part. Okay? This one. This is benzene. Then we have carbon. And here we have what? Oxygen. And this oxygen it has been attached with what? With one carbon, which is this one. And this carbon, it carries what? It carries 3 methyl group. So you can write just like this one. Plus what? So remember that this is denominator, plus this one. So this is still what? Let me write clear. This is our benzene. This is our carbon, which is still partially positive. Here you have our oxygen. You have a bond cis carbon. And then you have how many methyl surrounding that carbon? So 1, 2, 3. So I can write that I have CH3 and then 3. Okay, this is still what? So everything is okay there, but this is still partially positive. Plus what? Again, you have, that is all about you. We've taken the nucleophile, the electrophile, so it remains with chlorine, which is nucleophile. And while here carbons will act as electrophile. So why it's nucleophile? Because it is rich in electrons. Right? So what happens? So this nucleophile will bring its electrons to the electrophile. Hands-off electrons. The next thing, we have our benzene here. We have carbon, we have oxygen, we have carbon, we have CH3, 3. Then plus what? We have chlorine. Chlorine, but here I forgot the methyl group in this carbon. So even here we have the methyl group in this carbon. Fantastic! Wow! So that's the end product. It's the end of mechanism. So now we are writing the overall chemical reaction. Interesting. At least that now you are testing both dimensions of advanced organic chemistry. Because I know during your ordinary secondary education, you have never dealt with chemical reaction like this in this style. We are just claiming if you take methane, you react with chlorine, then all the hydrogens will be substituted under UV, under the presence of UV light. You claim, you write the reaction, and then you have been said that I'm a genius in organic chemistry. Okay, and then we say, fine, may God bless you. Try your level best to come in advance. Then we'll bless you with another organic chemistry. So this is a blessing. Okay? This is what? This is the blessing. And this is still a fundamental. So this is, we are still at the beginning. Still at the beginning of organic chemistry. So don't run. Stay there where you are and expect it again, amazing things of organic chemistry to come in your mind. Until I tell you that this is the end of organic chemistry, then believe me, you have many information. But I tell you the truth again. If you have a future or your vision is also relating with chemistry, especially chemistry or advanced chemistry, this program will prepare you to pursue that vision with not too much of hassles. Oh, I'll have to write reactant first. I've been happy to explain those informations to you. So I forgot that I have to write reactant first. So this is ketone, okay, now bond, CH3, and then starts reacting with what? With carbon, contains chlorine, then here we have CH3. How many atoms are there? 3. So this is the reaction. So what do you say? So you say that this is the point. So here it is. This is carbon. This is oxygen. This is C. CH3. 3. This guy, it is chlorine. That's the end product. Okay? Should I leave a homework for you in this part, or should I forgive you? Even if you say that, sir, forgive me in that part, I won't forgive you in near future. We'll be having many chemical reactions in future. So I'm looking for the homework for you in that part. So you try. I can't forgive you, because if I forgive you, I'll make you lazy at the beginning of the interesting business. Okay, so this will be example 6 here. Example 06B. Example 06B. So this is homework. I can't forgive you, because organic chemistry will not forgive you. Organic chemistry will not forgive you. I want to give you at least the simplest reaction. Yes, this is the simplest one. This is benzene, and here forming it contains localized pi bond, and then so you have a beautiful benzene again. So at least that we say, welcome to advanced organic chemistry. And this one will be reacting with C3 chlorine, but the condition under presence of water and hydrogen ion. So question complete. Reaction below with mechanism. So show me how do you get your end product. Okay, so if you do that business successful, then you have to give me permission to take you to the first interesting rule. This is the first rule. So I say that the first rule is contained with what? With the organic compounds, or with the chemical reactions. Organic compounds, or with compounds. They can be organic compounds, or let's say not only organic compounds, with compounds. So this is concerned with compounds. Either organic or inorganic compounds, which act as nucleophile. This the same types of nucleophile act as nucleophile by using the here lone pair. Your lone pair. So I taught you what the means of lone pair, just to go to the chemistry or general chemistry lectures, or even in session 2, I reminded you what the means of lone pair. Okay? So lone pair, okay, lone pair. So this rule states that if a compound acts as a nucleophile by using lone pair of electrons, atoms which supply the lone pair remain positive charged after netting this lone pair. This rule states that if the compound acts as a nucleophile, compounds acts as nucleophile by using HC lone pair electrons. Lone pair electrons. Then we say that when the atom which supply atoms which supplies the lone pair remain positively charged. Remains positively charged. Remains positively charged. Remain positively charged after donating the shorty its lone pair. Its lone pair. That's the rule. So then we say that this first rule is concerned with compounds which act as nucleophile by using the lone pair. So I told you that one type of nucleophile is compounds which contains lone pair. If a compound, this is stated that if a compound acts as nucleophile by using its lone pair, by using HC, possessive pronoun, its lone pair. Its lone pair. Okay, it's lone pair. It's lone pair what? Electrons. Act like it's, by using this lone pair electrons, then the atom which supply the lone pair remains what? Positively charged after donating its lone pair. So that is. So let us see an example. This is example 7. Complete the reaction below with what? By using mechanism. So where the reaction is. I say that this is CH3, have carbon, have the bond, have chlorine, then react with ammonia solution. What the end product? can pause the video and then you can do the mechanisms. Can pause the video and then try to do the mechanism of that chemical reaction, and you tell me in the comment section what your success. Positive for 3 minutes. Even yourself, you can take a piece of paper and try it. These students of mine are just waiting solution. I hate them. Okay? Solution. So you have a certain organic compounds which contain 2 carbons, 1 oxygen and 1 chlorine, reacting with ammonia, right? So ammonia is inorganic compound, right? It's an organic compound. So what's going on here? So listen. So we have pi bond, and also we have again something else, which is we have covalent bond, we have sigma bond, and we have something that we call lone pair. So solution. So first of all, you may get tempted to break the pi bond rather than the covalent bonds which have high electronegativity value. So plus what? Plus ammonium solution with lone pair. So ammonia contains a pair of electrons which are not used, a pair of covalent electrons which are not used in formations of covalent bond. That's what we call it, lone pair. Okay. Also, oxygen contains these 2 lone pair. Don't forget about that. But we are these rules concerning about organic compounds reacting with another compounds which contain lone pair. So then, what happens? So we have 2 alternatives. The first alternative, we might think that okay, we can break this bond and make this oxygen to be nucleophile, and this will make electrophile. Well, this is nucleophile, so this nucleophile will come to the electrophile. And that's okay, the bonds will be formed, the new bonds. But how about this nucleophile? Where will it get the electrophile? It's not there. So that's one of the limitations factor. Let me repeat, because my students here are just concentrating on watching me, they don't understand what am I saying. I say that here we have 2 ways that these organic compounds can undergo the chemical reaction. The first alternative way, or the first way, is maybe by using the third rule, right? And by the third rules, what happens there? We say that we can break the pi bond between the non-identical atoms, oxygen and carbon. If you break these bonds, this oxygen becomes nucleophile and this becomes electrophile. Okay, this is ammonium. So ammonium is the one of example of nucleophile which reacted by using the lone pair. So ammoniums want to donate this lone pair. So where will it donate? This is nucleophile, this is the electrophile carbons, this is the nucleophile oxygen. So this one, remember there's no reaction between nucleophile and nucleophile. I talked about that. So this nucleophile will come to the electrophile carbon. And one will be formed, fine. But here it remains with a nucleophile. Where will it get another electrophile to form a covalent bond? It's not there. So that's why that these reactions won't be successful, won't be possible. So you have to think again. The second alternative, we have how many covalent bonds? Covalent bond between carbon and carbon, carbon and hydrogens, carbon and chlorine, and even also this is the covalent bond, because it's formed by sharing of electrons between oxygen and carbon. But these carbons, so here we remember that oxygen is group 6 element, this is group 7 element, carbon is group 4. So remember that in the periodic table, as we increase, as you move from left to right, the electronegativity of atom increases. So chlorine is more electronegative more than oxygen. So if that's the case, the electronegativity difference between chlorines and carbons is higher than the electronegativity difference between carbon and carbon. First of all, the electronegativity difference between carbon and carbon is 0, and carbon and hydrogens is small, and carbon and oxygen is small. So we can break this bond. So you have to think yourself. I'm teaching you now the way of thinking before even you start writing. So if you break this bond, this becomes nucleophile, this becomes electrophile. Wow, so you have electrophile, you have nucleophile. We come to this side. What is this? This is nucleophile. So you can bring nucleophile into the electrophilic carbon. We form the bond. again we still have what? A hanging what? Hanging nucleophile. So you have to think again, which bond will be easier to break against to formulate another electrophile? So that electrophile and this nucleophile will combine together and form a neutral compound. And thus we have already accomplished the business that will be given as a chemistry student. Wow. Right? Hi. Let us know the business. You are allowed even to follow some steps. However, maybe your teacher are very interested in overall reaction. The first step. So the first step, we say that, okay, because I think that if I teach you this step, you'll understand. Break the covalent bond. Okay, the covalent bond between carbon and what? And chlorine. So you have what? So you have this is methyl. Here you have this is that bond, it's oxygen, this oxygen. And then say what? This is another bond, so it's chlorine. Okay, so you can write our ammonia there, but you don't catch it at this moment. Right? So what happens here? The bond will break down like this. Partially negative, this is partially positive. Alright? So if that's the case, we have what? You have CH3. You have this one, that bond is oxygen. This is partially positive. Then you have what? Chlorine, partially negative. Then you have what? Ammonia. Right? So if that's the case, we say fine. Okay. Fine. So then this is a electrophile. This is nucleophile. So remember that this is nucleophile, this is electrophile carbon, this is nucleophile. So you have two nucleophile and you have one electrophile. We cannot form the bond which we have broken. We have broken it. So we have to form a new bond. So this nucleophile will donate its lone pair to this carbon. Listen careful. Listen careful. Don't copy. So then we don't touch a bond between carbon and oxygen. Then what we say here, we have what? Ammonium with 3 bonds. Hence we say that plus what? Plus chlorine, which is partially negative or full negative, but this is nucleophile. So nitrogen has contributed its lone pair to form this bond. Right? But again, the compounds like this does not exist. Don't have any organic compounds of such molecular formula. Why? Because nitrogen can only form 3 covalent bonds. Can form 4 covalent bonds. Their nitrogens just form 4 covalent bonds. Carbon is only one. It's only atom that can form 4 covalent bonds. What does it mean? Let me write the open structure so you understand what am I saying. So this is double bonds, it's oxygen. Then this is, we have hydrogen here, so covalent bond, right? And then good. So here we have the bond between nitrogens. This is the bonds with hydrogens. So you see, carbons, okay, we don't have any problems with carbon. But here we have what? Chlorine. Whether it's partially negative or partially positive, it's partially negative. So this is nucleophile. So you have a problem here, right? So what happens? Well, so then we come back. We have formed a new bond between carbon and nitrogen. We don't expect to break it here once again. What happens? So can we have the existing organic compound? So we have to break one bond between nitrogen and hydrogen, right? Between nitrogen and hydrogens. Whether this one or this one or this one. Why do we want to break? First of all, we want to have existing organic compounds, whether in plant or in animal. Secondly, we still have a nucleophile. It needs an electrophile to form a neutral compound. So then, between nitrogens and hydrogens, which is more electronegative, is nitrogen. And hence, there's a high electronegativity. So what happens? So when this bond break, nitrogens will withdraw its electrons that has contributed, and nitrogens will become partially positive, but it means that meaningless positive, and this will become partially negative. This will become partially negative, and this will become partially positive. But this partially negative won't have any contributions as because nitrogen has already formed these 3 bonds, whereas it's lone pair. But this partial negative indicating that one bond of nitrogen has been broken. One bond of covalent bond has been broken, so the nitrogens withdraw all the bonding, all both pair of 40 of electrons. So then we say that this is CH3. Here you have carbons, double bond with oxygen. Then you have nitrogen. Here it remains is 2 hydrogen. So we can write this partial negative but meaningless. So we just ignore it, right? And then plus what? Plus chlorine, which is partial negative, plus hydrogen, which is partially positive. Right? So this is nucleophile. We donate electrons to electrophile and form a neutral compound. So simply we have CH3. Okay, we have C. Now bonds with oxygen. We have nitrogen, this one, and then we have what? Hydrogen chloride. Hydrogen chloride. That's the neutral molecule. And this is what we call T inorganic. We call T amine. Call it what? Amine, not amide. Is it amine or amide? Excuse me. That's what we call T amide. Say amide. Amide is the one of the derivatives of carboxylic acid. Johnson is not writing. It has been lost somewhere else. So amide. So now he's just smiling and doing nothing in the class. So it is called the amide. I'm looking the functional group of amide so that I can give you the right proportions amides. This is called amides. The difference, listen, the difference between amides and amine. Amides is this one. The difference between amides and amine, both they should contain ammonium with 2, it means nitrogen with 2 or hydrogen. But amides should contain double bond between carbon and oxygen, while amines does not contain the double bonds between carbons and oxygen. That's all. So for example, if I want to write amine of this structure, it will be CH3, it will be CH, it will be what? NH2. So this is amine, and this is amide. So this is amide, and this is amine. They're really confusing. But because you are still in the beginning, you can make jokes that, amine and amide, I can distinguish them. What? Fine. Wait, a day you realize that they are really challenging because these are close relating organic compounds. So overall reaction now. Overall reaction, because that was the first step, we break the bonds, then we count the second step. Where the second step? So this is the second step. Second step, we say that form new bond, right? And this the third step. So third step, say that third step, we say break bond, break covalent bond, break covalent bond. And then this one, we say that in the fourth step, form what? New bond. Form new bond. Overall chemical reaction. Overall chemical reaction. So you had it. You had CH3, carbon with oxygen, and then say chlorine plus what? Ammonia. And this will make what? So the end product is CH3. Now going to this guy, NH2, HCl. I'm not talking about the condition necessary for reaction take place. That's how we add up that value later on. Now I'm talking about the reactant side and the product side. But in organic chemistry, we are very clear about the condition. Sometimes it's heat, sometimes it's UV, sometimes it's some organic compounds. When organic compounds should be there are the conditions for the reactions to take place. Chemistry is beautiful. Organic chemistry is beautiful. Is beautiful. Is beautiful. Is beautiful. Is beautiful. Organic chemistry is beautiful, is beautiful, is beautiful, is beautiful. Do you like it? Okay, so now we can go and form another compound. This is example 8. Example 8. Example 8 is also homework. Homework 6. This is the first question. Complete the reaction below with mechanism, or by showing mechanism. So we're going to try it. It's simple. It's just alcohol. This bromethane, when it reacts with CH3 amine, give us the product. I'm not touching also about the concept of nomenclature. So it means it is bromoethane. This is called bromoethane, reacting with methylamine. Listen, this is called methylamine. Again, this compound is called the methylamide. Methyl what? Amide. Methylamide. That's called the methyl. We call the ethan. No, that is called ethan amide, or acetamide. Ethan amide. We'll learn about this. Don't worry that. I don't know. Maybe in session 40 or 50. I don't care about the number of sessions. What I care about the concept. Well, this is the end of this session 6. It's a time now for students to celebrate, because according to my experience of teaching students for more than 11 years, I know students always get happy at the end of the session. And another point, can I tell you another point that students they used to get happy? When they hear from the teacher that this is the end of this topic. Whether they understood or not, but they are always happy that now we have covered topic 1. But when they'll go for the revisions, they'll be crying once again that this stuff are too complicated. So this is the end of this session. I thank my Almighty God who have been with me on preparation. This is one of the challenging sessions that I was really praying to God to give me wisdoms on how I can simplify. Because it seems like we are teaching now our students some future or some complex reactions in future. So that's why that I've been trying my level best to simplify the contents. So I thank God also who have given you this chance to join me. May God bless you abundantly. And also I would like to pray to God to make sure that you understand all of these contents and you should not get confused. In case you have any question, ask in the comment section. Again, for you to get notifications from the YouTube community once we upload a new video, make sure that you subscribe our videos. We subscribe this YouTube channel that's called V&Vi, as what is called Tanzania Online A-Level Secondary School in square bracket OLENJOLAIM, so that you'll be enjoying many lecture videos that have been simplified and well prepared by using the syllabus of the United Republic of Tanzania. So don't forget to share these contents with your classmates, with your schoolmates, with all of your schoolmates, with anybody else who is enjoying the beauty of chemistry in his or her life. Okay, welcome to Tanzania. In case that you are not a Tanzanian, so if you're in Tanzania, enjoy the beauty of being a Tanzanian as a citizens. Okay, so again, I would like to invite you in session 7. Session 7, I will teach you about types of organic reactions. We won't discuss about those reactions you learned in ordinary chemistry, about the substitution reaction, double decomposition. Now, we have types of organic reactions which are very important. You have something called nucleophilic additional reaction, electrophilic additional reaction, elimination reaction. So basically we have 3 types of reactions, but within those 3 types of reactions, we have also some other types of reactions. So join me in that session, and then you'll enjoy the beautiful the general introductions of organic chemistry. So may God bless you, and I would like to meet you at that point. I'm praying for you, and keep praying for me. In case you want also to offer your thanksgiving, I don't want to forget, you are well invited to use this mobile number to send your free willing thanksgiving. So this telephone number 0759745331. Registered name is Olenjolai Tayai. That is my official name. And your thanksgiving will be received with the hands of thanks in order to make more lectures of organic chemistry to be in air through the internet, and you can take them at any time. And this, I think that, also tell me in the comment sections whether you have understood or you understand. Any kinds of the comments is really accepted. You understand where you enjoying these contents, in which place of this country, maybe that which school are you studying, which combinations are you pursuing, how do you find this online training, does it help you, what can you make to advance it? So any positive comments is welcome, and even questions, you can use the comment section. Again, I would like to remind you, make sure that you watch the session 00, the general introductions of organic chemistry, or the general introductions of advanced organic chemistry for A-level, or for Form 5 and Form 6, where I used to give you all the introductions, introduction for any students who want to go through this program. May God bless you. Meet you in session 7.